Hello students, this is Mr. Damiani, and today we're going to be looking at lesson 10.6, which is located on page 565 in the chapter 10 workbook. The topic for today's lesson is area of regular polygons. The essential question is, how can you find the area of regular polygons? So we're going to be pulling on some of the skills that we've developed through the first half of the chapter here to find the area of some more complex looking geometric figures here. So let's go ahead and take a look at the unlock the problem here. Please follow along. Emery is making a patch for his soccer ball. The patch he is using is a regular polygon. A regular polygon is a polygon in which all sides have the same length. I'm going to underline that. All sides have the same length and all angles have the same measurement. Emery needs to find the area of a piece of material shaped like a regular pentagon. All right, and if you think about a pentagon there, you're thinking of a five-sided figure. Basically one of these figures on that soccer ball. So let's go ahead and scroll down, look at what we're going to be doing. You can find the area of a regular polygon by dividing the polygon into congruent triangles. Let's make a special note of this. We're going to want to focus on finding the different congruent triangles within that regular polygon. In order to do this, you are going to draw line segments from each vertex, which is a corner where two lines meet, okay, to the center of the pentagon to divide it into 5 congruent triangles. All right, so we're going to go ahead and take care of that, that part right now. So here is a vertex, right here. That is your vertex, and we are going to draw a line from that vertex to the center point. Then from this vertex to the center point, and this vertex to the center point. And if you notice, you should have 5 equal and congruent triangles. All right, now if we find the area of one of these triangles and multiply that by 5, we should be able to locate the area of the entire pentagon. So here we are. You can find the area of one of the triangles if you know the side length of the polygon, which would give you your base, and the height of the triangle, which would give you your measurement from the vertex to the center. So you're looking down here at this triangle here, and we have a base and a height. So let's go ahead and scroll down, and we're going to fill in some of our information here. Sorry, I'm jumping around. Find the area of one triangle. So we're going to start by writing our formula. Triangle formula was A equals 1/2 BH, which you'll notice right here. The next thing I would like to do is I always go up to the diagram and I list down what I need. A, B, and H. We are looking for A. B is going to be the 20 centimeters, and the height is going to be the 14 centimeters. I'm going to take those values and we're going to substitute them into our equation, our formula. So A equals 1/2 times 20 times 14. So basically, we're going to think of half of 20, which is 10. I would normally have another line in here, but some of us can jump right down. So we're going to look at 10 times 14, 10 times 14, which is going to give me an answer of 140. So the area of the shaded region up here in red, one of those triangles, is 140 centimeters squared. Now, I want to count how many of those triangles I have. I've got 1, 2, 3, 4, 5 five sides of my figure, so that means I have 5 triangles. So I'm going to take that 5 and I'm going to multiply it by the 140 to get the total area. 5 times 140 is 700 centimeters squared. So the area of the pentagon-shaped piece is 700 centimeters squared. All right, so the only new step for us today is we're going to be multiplying that area of the triangle, by how many of those triangles we have. So pentagon, 5-sided figure, 5 congruent triangles. We took that 140 area, times it by 5 to get our 700. All right, so let's go ahead and turn the page, please, to page 565. 66. All right, here we go. Example 1. Find the area of the regular polygon. Step 1 tells me I first need to create my my congruent triangle. So I'm going to draw a line from the vertex of the figure to the center point. 1, 2, 3, 4, 5, 6. Looks like I have 6 different triangles for that hexagon. And I know that I should have 6 because I should have a 6-sided figure. 1, 2, 3, 4, 5, and 6. 6 sides, 6 triangles. And how many congruent triangles did you divide? We are looking at 6. Scrolling down, find the area of one triangle. Here we are. So I notice that I have a base here and I have a height here. So I do have a B equals 4.2 and an H equals 3.6. I'm going to use those values in my formula. Formula's been written. A equals 1/2 BH. We are now going to substitute our values in here. So I'm going to replace the B with the 4.2, and I'm going to replace the H with 3.6. So if you take these values and multiply them out, you remember you have your calculator available, you would get an answer of 7.56. And that is the area of this region here. But remember how many we had? 1, 2, 3, 4, 5, and 6. I have 6 triangles. So that means to find the area of the hexagon, you are going to multiply 6, because that's how many triangles I have, by the area of 1 to get a total area of 45.36 meters squared. So the area of the hexagon is 45.36 meters squared. So you find the area of 1, like I said, multiply that by how many you have for your total area. Let's go ahead and scroll down to question 1 right here. See if we can, get our brains working a little bit, thinking about what we're actually doing here. Into how many congruent triangles can you divide a regular decagon? By drawing line segments from each vertex to the center. All right, so a decagon, all right, if you remember, deca means 10, so I have 10 sides on a decagon. So how many triangles is that going to give us? Well, if we think about what we set up above here, the number of sides always equal to the number of congruent triangles. So in this case, we can create 10 congruent triangles. So 10 congruent triangles because a decagon has 10 equal sides. Good enough. Boom, there it is. Okay. All right, and that is because we're dealing with regular polygons. Remember, regular polygons have the same length sides right there. You can even make a note of that because these are regular polygons. If we had an irregular polygon, there's no rhyme or reason to those side lengths, so it's not as simple of a process. All right, let's move on to the next page here. Share and show. So now we're going to apply some of what we've been doing, and then I'm going to let you work a couple of your own, and we'll be done. All right, so what I would like you to do right now for me is I'm going to have you pause the video real quick, and I'd like you to try to fill in the information for question 1 step by step, and then we will go over how to do that. Thank you. Thank you for taking the time to pause the video here. Find the area, number of congruent triangles inside the figure. Well, I'm hoping you would have drawn your triangles, and then you would have said, okay, how many do I have? 1, 2, 3, 4, 5, 6, 7, 8. So I have an 8-sided figure, octagon. Therefore, I have 8 congruent triangles. Now, each triangle is going to be 1/2 5 times 6. So that's half of 5 times 6. That's the area of 1 here. What we're doing right now is we're finding the area of this triangle right here. And that area is going to be half of 30, which would give me 15 centimeters squared. And 8 times the 15, because I have 8 of the 15, or 8 triangles that all measure 15 centimeters squared, 8 times the 15 would have given me 120. So that's what you should have had. All right. Let's go ahead and look at question 2. Please follow along with my process here for question 2. I'm going to start by drawing my equal triangles. Good so far. I have a 5-sided figure. I know I'm going to have to multiply it by 5. You can even write that somewhere, somewhere around it, just to give yourself a reminder here. I get my formula down. A equals 1/2 BH. I know A equals, that's what we're looking for. I know B equals 6 and H equals 4. We'll worry about our units of meters after. Substitute in A equals 1/2 times 6 times 4. A equals 1/2 of 24, which A would equal, in this case, 12. So I know A equals 12. I also know that we have 5 of these triangles, so I'm just going to multiply by 5. So the total area here is going to equal 60 meters squared. And remember, as I'm going through, if I'm going too fast, you got to feel free to pause that video and take your time. The video lesson is designed to move at your speed. Okay. What I'd like you to do now is I'm going to have you circle questions 4 and 5. These are the 2 questions I would like you to do on your own. I'll get you started on question 4. I'm going to let you take it away and then finish up 5 independently. All right, so question 4, start by making your congruent triangles. Find your multiplier. In this case, I'm looking at a times 6 because I have 6 congruent triangles, and your formula. Okay, so here are your training wheels, and now you're going to be able to take it over. Before we close out the video, though, I want to remind my students to make your post-it note for the main idea. All right, trying to work on, starting to work on summarizing the video lesson. So please do that. Any questions, put on a post-it note as well. And I do have a riddle for those that are watching the video. Perhaps I'll give you some bonus points on maybe a missed homework assignment if you can answer the math riddle that I have here. And here it is. The question is, what did the baby tree say when it looked in a mirror? What did the baby tree say when it looked in a mirror? Come in with the answer to that riddle question, and bonus points will be heading your way. All right, thanks for taking the time to watch the video. I hope you all have a great evening, and make sure you come in with any questions and show your work for everything we're doing. All right, goodbye.